So design the general shapes below and extrude separately to get different parts. So we have to design this whole thing first. So let's do that. Let's create a new part studio. And the dimensions don't have to be exact for this. Let's just rectangle. Let's make this 1. Let's make this 5 or something. It doesn't really matter. Let's make this 1. Let's make this like 25, actually. That way we have more room to work with. Let's do this at 45 degrees. And this is perpendicular. Let's just make sure these are set to 1 inch apart. Okay, now we need to extrude these parts. And we can't extrude them all at once, because then we wouldn't be able to create separate parts for the hypotenuse, which the directions want us to do. So let's start by extruding this, and then extruding this as a new part. Now we have our hypotenuse. Now, assemble the two parts together so that the hypotenuse is as far into the corner as it will naturally go, which it currently is. The tricky part of this challenge is that you are required to assemble the parts such that when you go back to the part studio and change the length of the hypotenuse should shift into the right spot and you should not have to adjust anything in this assembly. So, if we weren't going to do that, and we were just going to, one thing we could do, part studio, we could just group this all together. And yay, now we have it in our right position. But if we were to change something like this, it's still going to work. But let's say you can't always group in the assembly, because sometimes you're importing like a piece of 820 from a different assembly, so you can't always group right away. You have to attach. So let's not do that. I should actually include that in the directions. Don't group anything. That is cheating. Now, what we could do is we could figure out how high above this is from here, and then offset it that certain amount. But then the problem with that is if we go back into our part studio and change the length of this, then to get it to go into the right spot, we'd also have to change the amount we offset it by. And doing that each time is a hassle. And we want to do it so that no matter how you change it in the future, the part always snaps correctly into place. So, we can use our parallel mate to create some restrictions on this. So, we select the two planes we want parallel. And then we can go into our limits and constrain them so the angle won't move. That's how it would move. Let's see. We never want the x-axis to change, so we don't want this sliding off. And we don't want the z-axis to change. This should be right up against the edge. The y-axis... Oh, what did I do? There we go. This should be able to move up and down now. Because no matter how we change the length of this, we should always have it so that it's touching this. Now we just do a parallel mate on the other side. And select check. And here it is in the correct position, but we're going to want to limit it because you could still drag this up since we didn't set any limits on this. Now, per our constraints on this, we're not going to be able to rotate this. So we don't have to worry about all this. We don't have to worry about all this. We just want the z-axis to always stay the same here. 0 inches apart. Give it a second to load and calculate. Yay! Now we have it in the right spot. It's parallel to both of these parts and constrained such that it can't move in and out and it can't move up and down. Now, we're in a scenario where if we change this, like let's drag this so it's teensy tiny, it should automatically adjust because the math stays the same. If we did that with just a simple fasten and an offset amount, it would still be offsetting by the same amount here that it previously was. But when we use the parallel mates, we get it so that no matter what the part studio dimensions are, it will always apply. And that's how you would do the hypotenuse setup puzzle.